One last one, I think. What reaction will take place at the cathode and the anode when each of the following is electrolyzed? Oh, actually, this is an important question.
Very.
All right, so if I have a KF solution, this is about competing reactions. Now, solution means you've also got something else present, and that is water. All right, so if I've got potassium ions, because it's KF.
Yes.
All right, it can go, you can add an electron, and you can turn it into potassium. Now, at this stage, we want to go back to our table. Okay. So if I look up in my table, so if I go to my table here, I need to find the chromium.
Lower right corner.
Lower right corner, so lower right corner over here. I need a darker pen, don't I?
Yep.
Black. You see it over here somewhere, Mr. Sams?
Yep, second from the bottom.
Oh, there it is. Negative 2.92 volts. So this is going to be negative 2.92 volts. Got it? The second reaction we have, we can F negative, and that can turn into F2.
Yes.
And that's 2, and then you'll have 2 electrons here. So if we go back to our table, actually I think we're going to have to top left corner, and that's going to be
2.87, but
since we're flipping it,
yes, negative 2.87.
So negative 2.87 volts. But there are 2 other reactions that are key. And folks, these reactions are the ones that we're going to have to watch. So if we go back to our table, we need to find the water. There are 2 reactions where water is critical. If I find the water, this is one of them right here.
Yep.
So I'm going to write that one. Mr. Sams is going to read it to me while I do this.
2 H2Os plus 2 electrons makes H2 plus 2 hydroxides. And it's negative 0.83.
And then if we go, and we need to find the other water one, and I believe it's right here, 1.23 volts. Positive.
Okay, got it.
Got it? So there it is, folks. You see that. Oops, wrong screen. And that's going to be what? Reverse reaction now.
Reverse reaction. Okay, 2 H2Os.
2 waters.
Becomes O2.
Becomes O2.
4 H pluses.
Plus 4 hydrogens.
And 4 electrons.
Plus 4 electrons.
So flipping it, it'll be negative 1.23 volts.
So now we've got 4 reactions, and then you can only have one thing oxidize and one thing reduce.
Right.
And so which ones are oxidizing and which ones are reducing? So this one is going, the first one is going down in charge, so this is reduction.
Yes.
Okay, this one is going up in charge, so that's oxidation. This one is, we can think of it this as gaining electrons, so it's reduction. GR, right? Leo says GR, and this is oxidation. And so essentially we have a competition between the 2 reduction reactions and then the 2 oxidation reactions. Now which one will happen, Mr. Sam?
The one with the big number.
Okay, which would be which one?
For the reduction? Yeah.
Now, it's the bigger number. Now, watch this, because it's the bigger number that, because negative 0.83 is bigger than negative 2.92.
Yeah.
We know that. And so, actually, potassium will not reduce. What will happen is you'll produce hydrogen gas.
Exactly.
So, the winner of this one is that you will produce reduction. You will produce this reaction. Now, if we look at the oxidation ones, let's change colors here. In blue here. We've got 2 competitions for oxidations, negative 2.87 and negative 1.23. The bigger number is
negative 1.23.
So the oxidation reaction will be this. So in fact, the potassium and the fluoride will do nothing in this particular reaction. So it says what happens at the anode, what happens at the cathode. Reduction occurs at the cathode. Remember, you keep your consonants together, and oxidation would be your anode. In fact, we just saw this reaction. Did we not?
We did.
This is, in fact, what we had. I put some salt in there. It could have been potassium fluoride. I used sodium chloride, but I got the same reaction. Okay? Now, we go back now to a similar kind of a thing. What about copper chloride? All right. Now, to do this, we're going to use the same. Since it's a solution, we're using the same 2 water reactions. So we can, I'm going to sort of abbreviate. The reduction of water, the voltages are negative 0.83.
Sorry.
And the oxidation of water, that was negative 1.23 volts. So my other options now are the copper 2 positive, because it's CuCl2, can go to copper plus 2 electrons. And now the voltage on this one, what's the voltage on this one? When you look at the table, I think it's
going down to elemental. Sorry.
Yeah, it is elemental. It's 0.34, I think, isn't it?
0.34.
0.34.
Yep.
Now, is it negative? Yeah, no, it's positive.
Positive.
So this
Yep,
one,
as
boy,
it
that
is.
blue may not be, it doesn't work very well, does it? Positive 0.34 volts. And this is being
That's reduction.
reduction. Now we can just look, reduction, negative 0.83, reduction 0.34,
0.34 wins.
0.34 wins. So this is going to be your cathode. My other option will be the chloride can go to chlorine gas plus 2 electrons. I don't know this one off the top of my head.
Chlorine is
Chloride to chlorine?
1.36, but it'll be negative.
Negative 1.36 volts. And so this is oxidation. Negative 1.23 wins.
Mhm.
So the water is going to oxidize, and the zinc is going to reduce. So this will be your anode. Yeah.
You said zinc.
Did I say it back? Oh,
You said
copper.
zinc. It's copper.
Do I smell something burning?
Mr. Meek was doing a demo in the back of the
Oh,
classroom.
okay. Good. We just didn't want to set the place on fire. That would be very bad. And that was a long podcast, so we apologize.
It was.
And we messed up, but
We
you guys
did.
figured it out.
But
so
you probably won't even see us messing up because we're going to edit it all out.
if you know how to do that, that's great, because
Good
I don't know
times.
how.
Oh, yeah. We can check it out.
Okay, so we'll be back at you. Talk to
Yep.
you later. Bye.